the last two lectures, we talked about the types of data and collecting data. How do you choose who you collect data from? Today, we'll talk about what do you do after you have the data? How do you organize the data, and how do you summarize the data? Let's take a look at example one. Example one is the following data lists the number of cars in a household. Let's also take a look at example two. Example two is the number of hours spent each week studying. So what type of data is example one and example two? Both of these are numbers, right? And they count or measure something. So both of these are quantitative data. Today, we're going to focus on just the quantitative data. We'll talk about qualitative data in another lecture. Example one, we're talking about the number of cars. So when we talk about number of cars, it doesn't make sense to have 2.31 cars, right? So example one is quantitative discrete. Example two, which is number of hours, it does make sense to talk about 2.31 hours. So example two is quantitative continuous. All right, back to example one. Example one, we're talking about the number of cars. Okay, we said this was quantitative discrete. Part A, constructive frequency, relative frequency, and cumulative relative frequency distribution. The word distribution is just a fancy way of saying make a table. So for part A, what we're going to do is just make a table that organizes my data. Okay, so I'm going to start off by, so the data here represents number of cars. And what I'm going to do is I'm going to list out all the data that I have, all the types, different data values that I have in my data, right? So I see zeros, I see ones, I see twos, I see threes, I see some fours, and it goes up to what? I see a 5. So I think it goes from 0 all the way up to 5. So we're going to list out all the different data values, which are 0, 1, 2, 3, 4, all the way up to 5. Okay, frequency. So the word frequency just means how many. So what I'm going to do is count how many zeros I have in my data. Okay, so I have 1, 2, 3, 4. I think that's it. So there's 4 zeros in my data. Okay, I'll tell you ones, there are 13 ones, 22 twos, 7 threes, 3 fours, and 1 5. Next up is relative frequency. What is relative frequency? So regular frequency, right, is counting how many. So this 4 means that there are 4 people who have 0 cars in their household. So then relative frequency is what percent is that? So what percent has 0 cars in their household? So what I'm going to do is I'm going to take the 4 and divide it by the total number of people. Okay, so what's the total number of people? You can count, right, how many data values you have. Or another way you can do it is just to count up all the frequencies. If I count up all my frequencies and add them up, right, that should tell me how many total people I have in my data. So if I add up 4 plus 13 plus 22 plus 7 plus 3 plus 1. Okay, and it's 50. And if you're paying attention, I also said 50 in the example. Okay, so there's 50 people total. So 4 out of 50 have 0 cars in their household. So 4 out of 50. So 4 divided by 50. Okay, on a calculator, I'm going to do 4 divided by 50. I'm using the Decimal Scientific Calculator, so just Google Decimal Scientific Calculator. That's the one that I'm going to recommend for this class. So 4 divided by 50 is 0.08. So for this class, if you need to round, we're going to round to 3 decimal places. But here, it's only 2 decimal places, so we don't have to round. Next up is 13 divided by 50. Okay, 13 divided by 50 is 0.26. Next up is 22 divided by 50. 0.44. 7 divided by 50. 0.14. 3 divided by 50. 0.06. And then 1 divided by 50, 0.02. Okay, think of relative frequency as a percent, right? So there's 4 people who have 0 cars in their household. 0.08 converts this to a percent. So you convert to a percent by moving the decimal point 2 to the right. So if I move it 2 to the right, it's just 8. So 8% of the people in the data have 0 cars in their household. 0.26 as a percent is 26%. So 26% of the people in my data have 1 car in their household. Okay, next up is cumulative frequency. And you might have heard the word cumulative before, right? In the context of cumulative GPA. So what's a cumulative GPA? So at the end of every semester, you have a GPA and then you have a cumulative GPA. So regular GPA is your GPA for that semester. Cumulative GPA is your GPA taking into account all the classes that you took before that also, okay? So that's exactly what cumulative frequency is. So the first cumulative frequency is always going to match the first regular frequency. So the first cumulative frequency is 4. The next cumulative frequency, right, is 13, but then you also want to include everything before it. So that's going to be 13 plus 4, which is 17. The next one is going to be 22, and then everything before it. So 22 plus 13 plus 4. So 22 plus 13 plus 4 is 39. Next is going to be 7 plus everything before it. So 7 plus 22 plus 13 plus 4. It's 46. Next up, 3 plus 7 plus 22 plus 13 plus 4. And I'll tell you that's going to be 49. And then finally, 1 plus 3 plus 7 plus 22 plus 13 plus 4, which we know is going to be 50, because that's all of them. And then finally, we have cumulative relative frequency. Okay, anytime you see the word relative frequency, it means find the percent, right? So we're going to take all these regular cumulative frequencies and then divide it by the total number of people, which is 50. Okay, so the first one is going to be 4 divided by 50. So 4 divided by 50, 0.08. Next up, 17 divided by 50. 0.34. 39 divided by 50. 0.78. 46 divided by 50. 0.92. 49 divided by 50, 0.98. And then finally 50 divided by 50, which is going to be 1. Okay, now that we've organized the data using a table or a distribution, we want to summarize it using a graph. So the main type of graph for quantitative data is going to be a histogram. So to draw a histogram, on the x-axis, the horizontal one, I'm going to go and list out all my data values. Okay, so I'm going to list out 0, 1, 2, 3, 4, 5. Okay, on the y-axis, I'm going to list the frequency. I'm going to put the frequencies. So on the y-axis, I'm going to do frequency. Okay, so if I look at my frequencies, right, they go from 1 on the low end all the way up to 22. Okay, so I'm going to count probably by 5s for my frequencies. So that's 0, 5, 10, 15, 20, 25. And histograms are going to be bars. All right, so I'm going to draw bars to represent the frequencies. Okay, so for 0 cars, the frequency is 4. So I'm going to draw a bar that has height 4. Okay, next up is 1. So for 1, it's 13. So I'm going to draw a bar that is height 13. Okay, next is 2, 22. Next is 7. Next is 3. And then finally 1. And that's a histogram. And then usually to make it easier for your reader, I'm going to label the heights of the bars. So this first bar was supposed to be height 4. So I'll just write 4 here. The next one is 13, 22, 7, 3, and 1. Okay, and that's a frequency histogram. So a couple things to note. Okay, note that the bars touch. So there's no gaps between the bars. Okay, there's going to be another type of bar chart where there are gaps, which we'll talk about in another lecture. Okay, and also notice that the bars are centered above the numbers on the x-axis. And this is only for quantitative discrete. Okay. So later on, when we talk about quantitative continuous, I'll say something different there. Part C, construct a relative frequency histogram. So this is going to be very similar to what we just drew. The only difference is this is a frequency histogram, so we put frequency on the y-axis. This is a relative frequency histogram, which means we're going to put relative frequency on the y-axis. And that's the only difference. So for the x-axis, same thing. I'm going to list out all my different data values. So this is from 0 to 5. 0, 1, 2, 3, 4, 5. And actually, I should actually say what these numbers mean. So these numbers are actually number of cars. Okay, let me actually do that for this one also. So on this x-axis, you should tell what these numbers mean. So these numbers are number of cars. Okay. Now, it's a relative frequency histogram, which means the y-axis is going to be relative frequency. And now the question is, how should I number this? If I look at my relative frequencies, they're all 2 decimal places, right? And they go all the way up to 0.44. So I think I'm going to go by 0.10, 0.20, 30, 40, 50. Okay. So this first one is 0.10, 20, 30, 40, 50. And then now bars. So for 0, it's 0.8. So 0.8 would be below 10. So that's somewhere down here. Next up is 2.6. Next up is 44. For 3, it's 1.4. For 4, 0.6. And finally 0.2. Okay, and then just like before, to make it easier for the reader, we're going to label the heights. So this first one was supposed to be 0.08. The next one was 0.26, 0.44, 0.14, 0.06, 0.02. And that's a relative frequency histogram. Okay, so now that we know what histograms are, let's talk about some terminology about the shape, talking about the shape of the histograms. So the first terminology is skewness. So skewness refers to the location of the tail. Okay, here's the histogram. Notice that you have a high point here, a peak here, and this part is the tail. Right, so this low part here is the tail. So the tail here is on the left side. This is called skewed left. This picture, the tail is on the right side. This is called skewed right. And then this middle picture, the peak's in the middle, and then you have 2 tails equally on the left side and right side. This is called symmetric. Now, what does this mean? Now, for skewed left, notice that most of the data is over here. All right, so most of the data is on the high side, and then you have a few on the left side. Okay, so for skewed left, what that really means kind of in real life is that most of the data is on the high side, and then you have a few data values on the left side, on the low side. So most data high, and then you have a few low. Skewed right, most of the data is over here on the low side, and then you have a few on the high side. So for skewed right, it's most of the data is low. And we have a few that are high. And then for symmetric, most of the data is in the middle. And then you have a few on the high side and a few on the low side. So in one of the labs later on, I ask you, for grades in a class, is it better for you if the grades are skewed left or skewed right? So think about that. Okay. Next terminology is modes. So modes are really just the number of peaks. This picture, there's one peak, right? It's called unimodal. Uni meaning one, and modal meaning mode. So that's one mode. This picture, there's two peaks. There's a peak here and a peak here. Bimodal, from the prefix bi meaning two. So that's two modes. Example 2. Here we're talking about number of hours. So we said it makes sense to have 2.31 hours. So it makes sense to have any decimal as a number of hours. This is quantitative continuous data. So what do you do differently? In example 1, right, because it was quantitative discrete, we were able to list out all of the data values. In example 2, because it's continuous, because you're allowed to have any decimal as a value, you can't just list out all of the decimals. There's just too many. So what do? You break up the data into chunks, or ranges, or classes is what it's officially called. So for the problems in this class, most of the time I'm going to tell you how to break up the data into ranges. In real life, you're just going to pick yourself. Okay. So for this problem, the ranges I'm going to break up the data into are 2 to 14.9, 15 to 27.9, 28 to 40.9, 41 to 53.9, 54 to 66.9. And now we can talk about everything that we talked about before. So frequency, relative frequency, cumulative frequency, and cumulative relative frequency. Okay, so frequency. Okay, frequency is just going to count how many data values are between 2 and 14.9. Okay, inclusive. So if you have 14.9, it goes here. Okay, so between 2 and 14.9, I'm just going to tell you, if you count, there should be 4. Between 15 and 27.9, there should be 10, 13, 9, and 2. Okay? So just trust me on that I counted correctly. That's frequency. Next up is relative frequency. Okay. Regular frequency, right, counts how many. So there's 10 data values between 15 and 27.9. Relative frequency, I want to know what percent does that represent. So what I need to do is divide these frequencies by the total number of people. Okay, the total number of people, just add up all your frequencies. Four plus 10 plus 13 plus 9 plus 2. $38. So there's 38 people here. I also said 38 here. So for relative frequency, it's going to be 4 divided by 38. Okay, on a calculator, 4 divided by 38. And I get a long decimal. So like I said, for this class, for everything, if you have to round everything to 3 decimal places. So rounded to 3 decimal places, this is 0.105. Next up is 10 divided by 38. 10 divided by 38. Rounded to 3 decimal places is 0.263. 13 divided by 38. 0.342. 9 divided by 38. 0.23, and this one gets rounded up to 7, 237. And then finally 2 divided by 38, 0.053. Next up is cumulative frequency. Okay, cumulative frequency, the first cumulative frequency should match the regular frequency, so that's going to be 4. Next one is going to be 10 plus everything before it, so 10 plus 4, that's 14. Next up is 13 plus 10 plus 4, so 13 plus 10 plus 4, 27. Next up is 9 plus 13 plus 10 plus 4, 36. And then finally 2 plus 9 plus 13 plus 10 plus 4, which is all of these numbers, which I know is 38. And then finally, we talk about cumulative relative frequency. And this is just take all of these regular cumulative frequencies and divide it by the total number of people, which is 38. So the first one's going to be 4 divided by 38. 0.105. Next is 14 divided by 38. 0.368. So remember, round to 3 decimal places. Next is 27 divided by 38. 0.711. Next, 36 divided by 38. 0.947. And then last, 38 divided by 38, that's going to be 1. And that's a distribution for quantitative continuous. So you break up the data into ranges or chunks. Now, you can also do this for discrete data, especially if you have too many possible values for the discrete data. So here, it was only between 0 and 5, so we could have listed that easily. But if we're talking about if we're talking about Twitter followers, right? So that could be from 0 to a couple million. So in that case, you probably do want to break up your data into chunks. Okay. So now let's talk about some terminology. Class, right? I said is the ranges. Okay. How many classes are there? How many ranges are there? 1, 2, 3, 4, 5. There's 5 ranges here. This is 5. What is the class width? Okay, so before I talk about class width, I need to introduce some more terminology. These ranges. Okay, the low number, there's a low number and there's a high number. The low numbers are called the lower limits. The upper numbers are called the upper limits. Okay. So class width is going to be the distance from a lower to the next lower. So in this case, 2 is the lower, 15 is the lower. So what is the distance from 2 to 15? So the easy way to do that is just take 15 minus 2. And that's 13. Okay, you can do this with any lower. So if I take 15, and then the next one is 28, right? 28 minus 15 is also 13. So all of the lowers are going up by 13. Right, so that's what the class width tells me. So all the lowers are going up by 13. Same thing for the uppers actually. Uppers are actually all going up by 13. If you check 14.9 to 27.9, that's going up by 13. 27.9 to 40.9, that's going up by 13. Midpoints. Midpoints, the way you calculate midpoint is lower plus the next lower divided by 2. Okay, that's how you calculate it. And now let's calculate it for this table. So let me do this in green. Okay, so the first one's going to be 2 plus 15 divided by 2. Okay, so on my calculator, so 2 plus 15 is 17, so this is really 17 divided by 2, 8.5. Okay, the next one's going to be 15 plus 28 divided by 2. All right, so 15 plus 28 divided by 2. 21.5. The next one, 28 plus 41 divided by 2. So 28 plus 41 divided by 2. 34.5. Next one, 41 plus 54 divided by 2. $47.5. So if you're using the decimal scientific calculator, you can just type it in and make it look exactly like that. If you're using any other calculator, which I actually don't recommend, you might have to do 41 plus 54 equals, hit equals, and then divide by 2. Or you need to put parentheses around the top. So I recommend using the decimal scientific calculator because just make it look exactly like that. Make it a fraction, on top 41 plus 54, and then on the bottom 2. And then, what about this last one? Because I have 1, 2, 3, 4, 5 classes, I should have 1, 2, 3, 4, 5 midpoints. So I'm missing one last midpoint. How do I find this last one? 54 plus what? What's the next one? So one thing I want to point out here. 8.5 to 21.5. What's the distance from 8.5 to 21.5? So subtract that. 21.5 minus 8.5. It's 13. What about between 21.5 and 34.5? 34.5 minus 21.5. is also 13. So my point here is these numbers are going up by 13, which is the class width. So what you could do is just do this formula and find that first midpoint, right? After you get the 8.5, you know that everything should go up by 15 or by 13. So starting with 8.5, you can just keep on adding 13, right? Add 13, add 13. And then for the last one, add 13. So 47.5 plus 13 is 60.5. So this last one is 60.5. And let me make a note of that. So I got this by doing 47.5 plus the width, which is 13. So that's what the width tells me. The width tells me that in my table, everything is going up by 13, right? The lowers are going up by 13. The uppers are going up by 13. The midpoints are going up by 13. Right? That's the significance of the class width. Okay, so we've organized the data using a table. So now let's talk about summarizing data with some graphs. We're going to talk about three types of graphs in the next couple of pages. So the first one is histograms. So frequency histogram and a relative frequency histogram. So for a histogram, we talked about histograms already. This is the bar chart, right? On the x-axis, we're going to put the lower limits. So this is going to be 2, 15, 28, 41, and 54. So 2, 15, 28, 41, and 54. Okay, and let me make a note of this. Okay, these are the lower limits. So first, let's do the frequency histogram. So frequency histogram is just telling me that I should put frequency on the y-axis. Okay, so actually let me label this x-axis also. The data here, what does this data represent? So this data represents, so these numbers represent number of hours that students spend per week studying. Okay, so this is number of hours per week. Okay, so frequency. Frequency, low end is 2. On the high end, it is 13. So you can choose how you want to count this out. I'm going to go by 5s. So 5, 10, 15. All right, the first frequency is 4. So this 4 is representing the range from 2 to 14.9, right? So this bar should be from 2 to 14.9. So it should be above the range 2 to 15. Okay, so I'm going to draw a bar at height 4 over the range 2 to 15. So height 4 is right here. The next frequency is 10, and that represents the range from 15 to 27.9. So I should draw a bar of height 10 above 15 to 28, the range 15 to 28. So height 10. Okay, next one is going to be 13. Next one is 9. Are we done? No. Right, I did 4, I did the 10, I did the 13, I did the 9. I haven't done the 2 yet. So the 2 should be another bar that's at height 2. Okay, so what's very important is I need this number right here. What is that number? So I have 2, 15, 28, 41, 54. What is that number there? Okay, there's two ways to get that number. That number should be the one that comes right after that. What's the number that's right after 66.9? That would have been right here, below the 54. So the number that's right after 66.9 is 67. So this is going to be 67. Okay, another way to get that is all my lower limits, right, 2 to 15, 15 to 28, all my lower limits, remember, are going up by the class width, right? So all I need to do to get the next lower limit is to add 54 plus 13. Right, 54 plus the class width should give me the next lower limit, which is also 67. Okay, and then just like before, I'm going to label the heights just to make it easier on my reader. So the first one is 4, and then 10, 13, 9, and 2. Okay, and that's a frequency histogram for quantitative continuous data. So a couple things I want to point out. So just like the example 1, the bars touch. And what I mean by that is that there's no gaps. The second thing I want to point out is the difference between example 1 and this example. So in example 1, the bars are centered above the numbers, right? So what I mean by that is that the numbers are centered in the middle of the bars. And that's okay. Well, that's what you're supposed to do for discrete data, right? Because this 13 represents how many ones there are, right? So this entire bar goes with this 1. And that's why you have the numbers centered on the bar. For continuous data, or any data where we're breaking up the data into ranges, the bars need to be above the range, right? So notice you don't have any numbers in the middle of the bar. Okay, and that's because this 4, right, doesn't represent just the 2 or just the 15, right? This 4 represents the range 2 to 15, or exactly 2 to 14.9, but we can say 2 to 15. So that's why for whenever you have data that's broken up into ranges, the bars should be over the range. In other words, you should never have any numbers in the middle of the bar. Okay, and so this is for, I'll say this, continuous. Okay, for our next picture, we're going to do a relative frequency histogram. So it's going to be exactly the same thing. The only difference is instead of frequency on the y-axis, we'll put the relative frequency. Okay. X-axis is going to be exactly the same. It's going to be the lower limits. So 2, 15, 28, 41, 54. And then we know that this is now 67. These numbers represent, or data represents, the number of hours per week that students been studying. And then I want relative frequency on the y-axis. Okay, so if I look at my relative frequencies, and if you follow my directions, they're all 3 decimal places. Okay, 3 decimal places, the 0.053 on the low end, and I think 0.342 on the high end. So I think the best way to count this out is to go 0.100, 0.200, 0.300, and so on. So I'll do this as 0.100, 0.200, 300, 400, 500. And I think that's all I need there. Okay, same picture, bars. The first relative frequency is 105. So 105 is, right, the bar goes above the range, right, because the 0.105 represents 2 to 14.9, the range from 2 to 14.9. Next up is 263. Next up is 342. Next up is 237. And then finally 053. 053 should be below this. So somewhere here. Okay. And then just like before, let's label the heights. So the first one is 0.105. The next one is 0.263. Next one is 0.342. 0.237, and then 0.053. Okay, and that is a relative frequency histogram. Histogram meaning bars, and then depending on whether it says frequency or relative frequency, that tells you what to put on the y-axis. And then x-axis for a histogram is lower limits. All right, so last part here, I want you to write sentences interpreting the second bar on the histogram. Okay, so let's start with the first picture, which is this one. Second bar is this 10. So what does this 10 mean? It usually helps me to interpret using the table. So this 10 came from this 10. So what does this 10 mean? There are 10. So we're talking about students here, and then these numbers are the number of hours they spend studying. So there's 10 students who spend between 15 and 27.9 hours studying. Okay, so that's a sentence. We said 15 and 27.9. That's actually hours per week studying. Okay. What about the second bar on the relative frequency histogram, which is this number right here? So whenever we talk about relative frequency, you should convert it to a percent when you write the sentence. 0.263 as a percent is 26.3%. So this is saying that 26.3% of the students spend between 15 and 27.9 hours studying. So actually, yeah, that's right. So the sentence we should write for the second one should be 26.3%. Of the students spend between what did I say, 15 and 27.9 hours per week studying. Now, this 27.9 you could say 28, right? Well, I'm not going to be too picky there. You could say there are 10 students who spend between 15 and 28 hours per week studying, right? If you're just looking at the picture, this 10 represents 10 to 28. So you can say 28 if you want. Okay, so I'll accept 28 here also. So that's if you're just looking at the picture, that's 26.3% spend between 15 and 28 hours per week studying. If you're going by the table, it's actually between 15 and 27.9. So either way, I'm fine. The next type of graph is a polygon. So for a histogram, which is what we just drew, for a histogram, we put the lower limits on the x-axis. For a polygon, we're going to put the midpoints, okay, which are these numbers here. So 8.5, 21.5, 34.5, 47.5, and 60.5. Okay, let me make a note of this, that we should put midpoints on the x-axis. Okay, and then just like before, the numbers on the x-axis represent, in our case, these are number of hours per week. Per week that students study. Okay, there's two types. There's a frequency polygon, which means you put frequency on the y-axis, and then there's a relative frequency polygon, which means you put relative frequency. Okay, so first one here, we put frequency. Frequencies, starting at 2, going up to 13. So let's count by fives. 5, 10, 15. Now, a histogram is bars. Polygons are going to be dots and lines. For the 8.5, the frequency is 4. Okay, so we're going to draw a dot at height 4. 21.5, frequency is 10. So draw a dot at height 10. 34.5, frequency is 13. Draw a dot at height 13. And then the next one is at 9. And the last one is at 2. Okay, dots and lines, connect these with lines. And that's a polygon. And then I'm going to label the dots with the frequencies so that it's easier for people to read. The first one, the frequency was 4. The next one was 10, 13, 9, and 2. And that's a frequency polygon. A relative frequency polygon, same thing. On the bottom, we're going to put the midpoints, so exactly the same as above. And these x-axis number, our data represents number of hours per week. Okay, and then for a relative frequency polygon, we're going to put the relative frequencies on the y-axis. My relative frequencies are these numbers. 3 decimal places here, and going up to 342. I'm going to go by 0.100, 0.200. And so on. 0.100, 200, 300, 400, and 500. And dots and lines. 8.5 is going to be 105.105. The next one is 0.263. The next one is 342. The next one is 237. And the last one is 053. So 053 is below 100. So that's down here. And then connect with lines. And then I'm going to label the points with the heights. 8.5 was 0.105. The next one was 0.263. 0.342. 0.237. And then finally 0.053. And that's a relative frequency polygon. So once again, midpoints on the x-axis, and then the graph is dots and lines. Last part, write a sentence interpreting the third point on the polygon. So this is this 13 here. So the 13, I recommend interpreting it by using the table, okay? Because if you just look at the graph, it looks like this 13 is 34.5. So it doesn't mean that there's 13 students who spend 34.5 hours studying, because really the 13 represents 28 to 40.9. So there's 13 students who spend between 28 and 40.9 hours studying, okay? So for polygons, I recommend going back to the table and then interpreting it from the table. So the 13 means that there's 13 students who spend between 28 and 40.9 hours per week studying. And 40.9. Okay. The third point on my relative frequency polygon is this one, which from my table is this number. So this number, anytime you interpret a relative frequency, convert it to a percent. So convert this to a percent, move decimal 2 to the right. So that's 34.2. So 34.2% of the students spend between 28 and 40.9 hours studying per week. That's 34.2%. Whoops, sorry. 34.2% of students spend between 28 and 40.9. The last type of graph is an ogive. So for histograms, we put lower limits on the x-axis. For polygons, we put midpoints on the x-axis. For ogives, we put upper limits on the x-axis. Okay, so upper limits being the upper of the ranges. So 14.9, 27.9, 40.9, 53.9, and 66.9. These are the upper limits. And then on the x-axis, these numbers represent our data. Our data here are number of hours per week. Now, ogives are the trickiest because even though it says frequency ogive, what do you put on the y-axis? You don't put frequency. So ogives, you always have to add the word cumulative to it. Okay, so even though it says frequency ogive, what you should put on the y-axis is cumulative frequency. So my cumulative frequencies is this column here. So 4, 14, 4 in the low end, and then it goes all the way up to 38. So I think I'll count by tens here. So 10, 20, 30, 40. And this graph is going to be dots and lines, okay, just like the polygons. Except this time you're going to be using the cumulative frequencies. So the first one is going to be 4. Oops, that's down here. The next one is 14. Next one is 27. Next one is 36. And then last one is 38. And then connect these dots with lines. And then I'm going to label the dots with the heights. So these are the cumulative frequencies. So it's 4, 14, 27, 36, and 38. And that's a cumulative, or that's a frequency ogive. A relative frequency ogive, same thing. We're going to put upper limits on the x-axis. Okay, these are the same numbers: 14.9, 27.9, 40.9, 53.9, 66.9. And then the data represents number of hours per week. Okay, it's called a relative frequency ogive, but ogive, always add the word cumulative to it, so you should actually be putting cumulative relative frequency. All right, my cumulative relative frequency, 105, 0.105, all the way up to 1.000. So I think I am going to go by, how should I do this? I think I'll make it easier myself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and each one of these is 0.100, 0.200, 0.300, 400, 500, 600, 700, 800, 900, and then 1.000. All right, the first one, cumulative relative frequency is 105, 0.105. That's right here. The next one is 0.368. Next one is 0.711. Next one is 0.947. This one here. Last one is 1, all the way up here. Connect with dots. And then I'm going to label the dots with the heights. So the first one is 0.105. The next one is 0.368. Next one is 0.711. This dot was 947, 0.947. And then the last one is 1. And that is a relative frequency ogive. Okay. Key points: upper limits on the x-axis, and remember to always stick the word cumulative on it. Okay. So let me actually box this just to emphasize. Because I don't want you to get that wrong on a test. Okay, last part here, interpret these numbers or these graphs. Right, since interpreting the 4th point on the ogive. So 1, 2, 3, 4. So I'm talking about this 36. All right, so I think it's easiest to go back to the table. This 36 is right here. So this is saying that there are 36 students. Now the tricky part here is this 36, what is this 36 representing? Is it representing just 41 to 53.9? No. Remember, for cumulative frequency, how did we get this 36? We got this 36 by doing 9 plus 13 plus 10 plus 4, right? We did 9 and everything before it. So this 36 represents actually 2 to 53.9. So there are 36 students who spend between 2 and 53.9 hours per week studying. Okay. And 53.9 hours per week studying. Okay, if you want to be lazy, you can also say there are 36 students who spend 53.9 or less hours per week studying. Right, so or less takes care of like everything below it. The next one is the 4th point is 1, 2, 3, 4. This 94.7. Okay, anytime we're talking about relative frequencies, convert it to a percent. So that's move the decimal 2 to the right. That's 94.7%. So 94.7% of students spin between, so once again, this 0.947 doesn't just represent this range, right? It represents this range and then everything before it. Because anytime you're talking about cumulative, you always include everything before it. So this 0.947 represents this range from 2 to 53.9. Example 3. We have some data, and it says construct a frequency, relative frequency, cumulative frequency, and cumulative relative frequency distribution. In other words, make a table. Using a class width of 3 and using 7 as the lower class limit of the first class. This is telling you how I want you to break up your data into ranges. Okay, let's go back to the terminology. Classes are the ranges. The lower number of each range is called lower limits. the upper number of each range is called an upper limit. Okay, this is saying using 7 as the lower class limit of the first class. In other words, use 7 as the lower number of the first range. So what I'm telling you here is I want you that first range to be 7 to something, and then class width of 3. So here in my previous example, example 2, the class width was 13. And 13 is telling you what all these numbers are going up by, right? The lowers are going up by 13, the uppers are going up by 13, the midpoints are going up by 13, okay? So class width of 3 is telling me that the lowers should go up by 3. So 7 plus 3 is 10, plus 3 again is 13, plus 3 again is 16, plus 3 again is 19, and I think I don't need to go any further because my data tops out at 16.53. Okay? My lowers are going up by 3, the class width. Now, how do I find the uppers? 7 to what? So this number should be just below that next lower. So what number is just below 10? 9. Okay, and then if I look at my data has 2 decimal points, right? So my uppers should also have the same number of decimal points. So 9 point, what number is just below 10 and has 2 decimal points? 9.99. Okay, for this next range, it should be, this upper should be just below the 13. So just below the 13 is 12.99. This range, this upper should be just below 16. So just below 16 is 15.99. This upper, just below 19, 18.99. And then what about this last one? Remember, class width is 3 is telling me that all my numbers should go up by 3, right? My lowers go up by 3. My uppers are also going up by 3, right? 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 3 is 18. 18 plus 3 is 21. Okay, and then from here, frequency. So you're going to count how many data values are between 7 and 9.99. So let's count here. That counts. That counts. And I think that's it. So there's 2 between 7 and 9.99. And I'll tell you the other ones. The other ones are 3, 5, and 2. So we didn't need this last one anyway. Okay? And then from here, you would find the relative frequency, the cumulative frequency, and the cumulative relative frequency, which I think you know how to do. Okay, so I won't do that here. Example 4. So here we have a histogram. Okay, we have a histogram. And really this question is, if I give you a histogram, can you go backwards and make the original table for me? Okay, so what I need to do is figure out the ranges. Okay, how do I make the ranges? Back to my histogram. Do you remember what goes on the x-axis of a histogram? What are these numbers? Are they the lowers? Are they the uppers? Are they the midpoints? If you go back to when we talked about histograms, right? The numbers on the x-axis of a histogram are always the lower limits. In other words, these numbers are the lower numbers of my ranges. Okay? So these numbers here are my lowers. Which means 15, 30, 45, 60, 75, and 90 are the low number of each of my ranges. So my classes, my ranges should be 15 to something, 30 to something, 45 to something, 60 to something, 75 to something, 90 to something. Now, how do I find the uppers? So just like in the previous example, right, look at the next lower and just go slightly below. So slightly below 30 is 29. Now, how many decimal points should I use? So in the last example, I said you should match the number of decimal places with your data, right? If there's 2 decimal places in your data, you would put 0.99. So here, we don't have the original data. So it's okay to just use a whole number. You can put 29.99 if you want. But because we don't have the data, you can just use whole numbers. The next one should be slightly below 45, which is 44. The next one is slightly below 60, 59. The next one, slightly below 75, which is 74. Slightly below 90, which is 89. And then what about this last one? So for the last ones, it's always easiest to use the class width. These numbers are going up by how much? 15 to 30, it's going up by how much? 15, right? So 30 minus 15 is 15. From 30 to 45, that's going up by 15. 45 to 60, that's going up by 15. All the numbers in this table should be going up by 15, right? So to get this last one, just add 15 to the 89. So 89 plus 15 is, what is 89 plus 15? $104. Okay, and then I need to find my frequencies. So this is a frequency histogram, which means the heights are frequencies. Okay, so my frequencies are just 12, 3, 4, 3, and 2. And I didn't need this last one anyway. And then from here, I think you know how to find the other columns, so I'm not going to go through that. Example 5. Here we have an ogive. And the question is, if I give you an ogive, can you go backwards and make the table for me? So this is a really a question of how do you make the ranges? So you have to think back on an ogive. What are these numbers on the x-axis? So if we go back to when we talked about ogives, right? For an ogive, the number on the x-axis are the upper limits. So these numbers down here are my upper limits. Which means these numbers are the high numbers on each of my ranges. Okay, so my ranges should be something to 54.9, right? Something to 79.9, something to 104.9, something to 129.9, something to 154.9. And then the question now is, how do I find my lowers? So I think it's easiest for this one to start at the bottom. So this lower should come right after this 129.9. So what number is right after 129.9? 130. This lower should come right after 104.9. What number is right after 104.9? 105. This number should come right after 79.9. That's 80. This number is the number that's right after 54.9. That's 55. And then the hard one is this first lower limit. So to find this first lower limit, figure out what your numbers are going up by. What are your lowers going up by? So from 55 to 80, that's going up by how much? So to figure out, just subtract. 80 minus 55 is what? I think it's 25, right? From 80 to 105, right, is going up by how much? I think it's going up by 25 also. 105 to 130 is going up by 25. So your lowers are all going up by 25. That's the class width. All your numbers here are going up by 25. So to find this last one, just go backwards. 55, go down by 25. And what is that? So 55 minus 25 is 30. Okay, and that makes all of the lowers go up by the same amount. So all the lowers are going up by 25 in this example. And then we have to find the frequency. Three, 7, 13, 20, 26. Are these the frequencies? Say no, they're not. Right? 3, 7, 13, 20, 26 on an ogive are cumulative frequencies. So these numbers are actually the numbers that go in this third column, cumulative frequency. So the cumulative frequency we know are 3, 7, 13, 20, and 26. Now, can you go backwards and get the regular frequencies? So we know that the first frequency, first regular frequency and cumulative frequency, they should match. Right? So this one is 3. Okay. The next one. The next one, remember how cumulative frequencies work. So this 7 should be 3 plus whatever goes here, right? So 7 is 3 plus blank. So 3 plus blank is 7. What is that blank? 3 plus what equals 7? 4. Okay. The next blank, 3 plus 4 plus blank is 13. So 3 plus 4 is 7, right? 7 plus what is going to give me 13? 6, right? 6 is going to work. So 3 plus 4 plus 6 gets me to 13. 3 plus 4 plus 6 plus what gets me 20. So 3 plus 4 plus 6 so far is 13. 13 plus what is going to give me 20? 7, right? And then finally, 3 plus 4 plus 6 plus 7 plus what is going to give me 26. 3 plus 4 plus 6 plus 7 together is 20. So 20 plus what missing number will give me 26? 6. Okay, and then from here, I know you guys know how to find the relative frequency and then the cumulative relative frequency. So I'm not going to do that here. Have a good day, and I will talk to you guys later.